Hello, hi everyone. Welcome to the Student the Brain. This is your Siva sir. Today topic is electric current. Electric current. Electric current is nothing but rate of flow of charge. I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of charge is coulomb. And SI unit of time is second. I equal to Q by T. Second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called 1 ampere. Now charges are moving inside of the conductor. So you can see charges are moving inside of the conductor. We can't say 1 electron, 2 electron. So 1 charge, 2 charge, if it goes, we can't say current is flowing. So there are number of charges are moving inside of the conductor. So positive, negative, positive, negative, positive, negative. There are many charges are moving inside of the conductor. So then only we can say current is passing through the conductor. Okay, current is passing through the conductor. Now I equal to, so here number of charge. Charge is the quantization of charge is nothing but quantization of charge. Okay, so this is called quantization of charge. This is called quantization of charge. Okay, here 1 electron, 2 electrons, if it is flows, we can't say current is flowing. Okay, so we can say if number of charges are moving inside of the conductor, then we can say current is flowing. So I equal to Q by T, 1 ampere equal to 1 coulomb per 1 second. Quantization of charge is equal to plus or minus Ne. So N on one electron, on one electron, 1.6 into 10 power minus 19 coulomb is present. 1.6 into 10 power minus 19 coulomb. So in 1 coulomb, 1 by 1.6 into 10 power minus 19, that is 1 by 1.6 into 10 power 19, that is 1 coulomb. Now if you are taking 1 coulomb, that is, so 1 by 10, okay, so 1 by 1.6, that is 10 by 10 into 10 power 19, then you'll get 10 by 16 into 10 power 19, then you'll get 1 coulomb. So if you do this, you'll get 0.625 into 10 power 19, then you'll get 6.25 into 10 power 18 electrons are present. 18 electrons are present, right? So on 1 electron, in 1 coulomb, 6.25 into 10 power 18 electrons are present. In 1 coulomb, in 1 coulomb, in 1 coulomb, you can see here, In 1 coulomb, 6.25 into 10 power 18 electrons are present, right? Yes, so this is about electric current. Once again, I equal to Q by T, SI unit of charge is, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. So number of charges are moving, then only we can say current is flowing. That is quantization of charge on 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19. In one coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? That is a question. So 1 coulomb 6.25 into 10 power 18 electrons are present, right? Next, we will discuss about one more point, that is electrical appliances. Electrical appliances we'll discuss. Now, now you can see. So cell, this is the cell, positive terminal, negative terminal. Coming to the second one, battery, positive terminal, negative terminal. Coming to third one, third one. So cell I am taking, this is the cell, positive terminal, negative terminal, cell, battery. So open switch, closed switch, open switch and closed switch. Coming to the fifth one, resistor. This is the resistor. And coming to the sixth one, so rheostat. Either we can take like this or we can consider like this also. Okay. So cell, battery, open switch and closed switch. Now you can see this is the cell, battery, open switch, closed switch, resistor, rheostat, So here, so this is either this one or this one, both are rheostat only. Okay. Now coming to the seventh one, ammeter. This is ammeter. Coming to the eighth one, voltmeter. Coming to ninth one, battery, bulb. This is the bulb. 10th one, wire joining. 11th one, wire crossing. Okay. Check once here. So cell, battery, open switch, closed switch, resistor. rheostat, ammeter, voltmeter, bulb, wire joining, wire crossing. Here, resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Okay. So rheostat is a device. Rheostat is a device. So rheostat is a device which is used to regulate the current without changing the voltage source. Regulate the current without changing the voltage source. And coming to the ammeter, ammeter is a device which is used to measure the electric current. So voltmeter is a device which is used to measure the potential difference. Ammeter is connected in series, voltmeter is connected in parallel, and a bulb, here wire joining, wire crossing. These are the electrical appliances. Electrical appliances. Next one, coming to the electrical circuit. So we'll discuss about electrical circuit. Now, electrical circuit. Electric circuit is nothing but continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current. So I'm taking this is a battery. This is a battery. So I'm taking the ammeter here and bulb. So current is flowing. So current is flowing, bulb is glowing. Now you can see a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Okay, so current is flowing like this. So here there are 2 points are there. So one is conventional current, another one is electric current. Conventional current is nothing but conventional current. So the flow of positive charges, conventional current. The flow of positive charges is known as conventional current, whereas electric current is nothing but electric current. The flow of electrons. So conventional current is nothing but flow of positive charges. Electric current is nothing but flow of electrons. Flow of electrons. Okay. Right. Now, so you can observe a continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. So flow of positive charges is known as conventional current. Flow of flow of flow of electrons is known as electric current. Flow of electrons is known as electric current. I hope it is very clear to you. I hope it is very clear. Now we will discuss about one more. Okay. Now potential difference and electrical potential will discuss. Now potential difference and electrical potential. So potential difference is nothing but, okay. So here potential difference and electrical potential. Potential difference and electrical potential. So we are A and B. We are doing some work to bring unit positive charge from one point to another point within the conductor. We are doing some work to bring unit positive charge from one point to another point within the conductor is called potential difference. So here positive charge is there. We are doing work. So V equal to W by Q. So 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor is called potential difference. Coming to the electrical potential, electrical. So what is electrical potential? Electrical potential is nothing but work done to bring unit positive charge. So normally potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So work done to bring unit positive charge. So I am taking the positive charge. This is infinity. So we are doing some work to bring unit positive charge from infinity to the required field. So we are doing some work to bring unit positive charge from infinity to the required field is called electrical potential. So same formula we'll discuss. Okay. So here you can see potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Coming to the electrical potential, work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Electrical potential. So now we will discuss about one more, that is about Ohm's law. Ohm's law will discuss. Ohm's law, right? Come on. Now you can see here Ohm's law will discuss. Ohm's law. Ohm's law. Ohm's law is nothing but so the potential difference across the ends of the given metallic conductor. Okay, so here resistor I am taking here, so switch, ammeter, this is the ammeter, so current is, so here I am taking the battery, positive terminal, negative terminal, current is flowing. Okay, the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor, so is directly proportional to current flowing. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. V equal to IR. So now we will discuss about one more. Materials required. Materials. So what are the materials required? First one is nichrome wire. So sorry, four cells, four cells, four cells of 1.5 volts of each. And second one is nichrome wire is an Li of nichrome wire. Nichrome wire is an Li of 1.5 volts. So nichrome wire 0.5 meter length, 0.5 meter length, 0.5 meter length. And coming to the third one, so third one is, so here you can observe four cells of 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Okay. Now, ammeter, and coming to the fourth one, voltmeter, and fifth one is switch, and coming to sixth one, connecting wires. Okay, so procedure, first connect one cell, procedure, first connect one cell and note down the reading of ammeter and voltmeter. One cell you have to connect and note down the reading of ammeter and voltmeter. Next connect two cells and note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. So repeat the process for 3 and 4. So 3 cells and 4 cells, and mention repeat the process for 3 and 4. Okay, and mention in the tabular form given below. So I am drawing the tabular form. Serial number of cells, ammeter, voltmeter, V by I form. Okay, so now you can see here serial number of cells. So ammeter reading, voltmeter reading, V by I form, that is R. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So if you draw the graph for okay, so if you draw the graph for VI, V on y axis, I on x axis. So the graph is linear. The graph is linear. Okay. I hope it is very clear. If you draw the VI graph, the graph is linear. The graph is linear. And this is for ohmic conductors. If you draw the graph, so V on y axis, I on x axis, V on y axis, I on x axis. The graph is curved. The graph is curved for non-ohmic conductors. Non-ohmic conductors. Ohmic conductors and non-ohmic conductors. So ohmic conductors means the conductor which obey Ohm's law. The substances which obey Ohm's law, those are called ohmic conductors. So the substances which does not obey Ohm's law, they are called non-ohmic conductors. So here I am taking ohmic conductor graph is linear, non-ohmic conductor graph is curved. So definitely one question will come. So surely explain about Ohm's law, related to Ohm's law, surely one question will come. So procedure statement is, so at a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Okay. Okay, so materials require 4 cells of 1.5 volts each, nichrome wire 0.5 meter length, ammeter, voltmeter, switch and connecting wires. Procedure: first connect one cell and note down the reading of ammeter and voltmeter, connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. So what are the values you are getting? Those values you can mention in the tabular form. If you draw the VI graph, the graph is linear. The graph is linear for ohmic conductors. The graph is curved for non-ohmic conductors. The graph is curved for non-ohmic conductors, right? Yes. Now we will discuss about resistance and resistivity. Resistance and resistivity will discuss. Now resistance and resistivity will discuss. Resistance and resistivity. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. Okay. So R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So here you can observe R is the resistance, rho is the resistivity, R is the resistance, rho is the resistivity. R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. So here R is the resistance, rho is the resistivity. Okay. So now SI unit of resistivity. SI unit of resistivity. So we'll discuss about SI unit of resistivity. Now you can see here rho equal to RA by L. So SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter, rho equal to ohm meter, I hope it is very clear. Check once. So R equal to rho equal to RA by L. SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter, meter get cancelled. Then rho equal to ohm meter. Okay. So I hope it is very clear. Just check once. Very important. Very important. So very important. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. Rho equal to RA by L. So here SI unit of resistance is ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled. SI unit of resistivity is ohm meter. Now we will discuss about differences between resistance and resistivity. So we'll discuss about differences between resistance and resistivity. Okay. Now you can see here. So resistance and resistivity. So R equal to rho into L by A, first equation. Rho equal to RA by L. Coming to the second one, resistance is ohm, and here ohm, SI unit is ohm, and resistivity is ohm meter. Here third one is symbol, ohm meter. Coming to the fourth one, so SI unit of resistance depends on length and area of the cross section. Depends. So here fourth one, so it does not depend on length and area. Does not depend on length and area, right? And coming to the fifth one, so resistance depends on temperature. And material also. Sixth one, material. And here also, so resistivity depends. This is a resistance and here resistivity. resistivity, okay. So fifth one, resistivity depends on temperature. Resistivity depends on temperature. Coming to sixth one, resistivity depends on material of the conductor also. Material of the conductor. So these are the differences between resistance and resistivity. I hope it is very clear. Once observe. Once observe here. Okay. So here, resistance R equal to rho into L by A. SI unit of resistance is ohm. SI unit of resistivity. So here, SI unit of resistivity is ohm meter. Ohm meter symbol is this one. And coming to the resistance depending factor, resistivity does not depend on this length and area. Resistance depends on temperature and material of the medium. Here also same thing. Okay. Yes, material only I mentioned. Okay, here. Okay, done. Clear? Okay, fine. Next. Resistivity is equal to resistivity is equal to R equal to rho into L by A. Rho equal to RA by L. So resistivity is equal to resistance of the conductor per unit length. R by L into A. Resistivity is equal to resistance of the conductor per unit length and unit cross section area. Resistivity is equal to resistance of the conductor per unit length and unit cross section area, right? So this is about resistivity. Okay, done. So actually resistivity depends copper wire, silver, gold, iron. So here for only copper it will be resistivity depends on only copper wire. So coming to the silver wire or gold like a different material. Okay, resistivity varies with material. Okay, even resistance also. So that is the example. So different materials if you take, resistivity and resistance both will change. But particularly resistivity depends on material of the conductor. So resistance, even though resistance depends on length and area of the cross section, but resistivity depends on material, even temperature also. So based on the so it's a property of the material. It is a property of the. Okay, done. Then so we'll discuss one more. So factor depends on resistance already completed. Difference between resistance and resistivity completed. Now we will discuss about resistors are connected in series combination. Resistors are connected in series combination. So let's start. Okay. Now you can see here. So here I'm taking one resistor, another resistor, three. So 3 resistors I am taking R1, R2 and R3. So potential difference V1, V2, V3. So I am taking the cell battery. So I am considering the battery. Current is flowing here, right? So here current is flowing. So current is same. Is equal to I1 equal to I2 equal to I3 equal to I. Current is same throughout the circuit. Current is same throughout the circuit. So but potential difference is different. Potential difference is different. So now you can see here Vs equal to V1 plus V2 plus V3. So IRs equal to IR1 plus IR2 plus IR3. So I am taking common, then I am taking carbon R1 plus R2 plus R3. So then, so I get cancelled. So RS equal to Rs equal to R1 plus R2 plus R3. So total resistance in series combination is equal to, so sum of R1, R2, R3. So Rs equal to R1 plus R2 plus R3. I hope it is very clear. If number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, so Rs equal to Nr. So throughout the circuit current is same. Throughout the circuit current is same. Vs equal to V1 plus V2 plus V3. IRs equal to IR1 plus IR2 plus IR3. I get cancel. Rs equal to R1 plus R2 plus R3. Rs equal to R1 plus R2 plus R3. Rs equal to Nr. Rs equal to Nr. Right? I hope it is very clear. Now let's start. Resistors are connected in parallel combination. 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 So now you can see here. R1, R2 and R3. So current is dividing whatever the current is flowing here. So that same current is dividing into three parts, R1, R2, R3 across. So current is dividing into three parts, I1, I2, I3 across R1, across R1, I1, across R2, I2, across R3, I3. Okay, so now current is different from Ohm's law, V equal to IR. From Ohm's law, V equal to IR, I equal to V by I equal to V by A. So IP equal to I1 plus I2 plus I3. So V by RP equal to V by RP equal to V by R1 plus V by R2 plus V by R3. V by R1 plus V by R2 plus V by R3. So we get V, I am taking common, 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So V I am taking common, we get cancelled. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. I hope it is very clear. Is it clear? Check once here. So current is dividing into three parts. So through R1, I1, through R2, I2, through R3, I3. I1, I2, I3. So IP equal to I1 plus I2 plus I3. Okay. So V by RP equal to V by R1 plus V by R2 plus V by R3. V I am taking common, V will get cancelled. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So then we will get the final formula 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3 because V is common. I hope it is very clear. Next one. Next. So we'll discuss about one more, that is okay. Now heating effect of electric current. So now we'll discuss about heating effect of electric current. Heating effect of electric current. Heating effect of electric current. Electric current. Okay, so that is V equal to W by Q. W equal to VQ. P equal to W by T, that is nothing but VQ by T. Q by T is nothing but I. So once again listen carefully. V equal to W by Q. W equal to V into Q. P equal to W by T. W equal to VQ. Q by T is I. Now, so P equal to VI. So energy is given to the conductor certain time, that is given to the heat. So Vi into T, V equal to IR, V equal to IR, H equal to IR into I into T. So H equal to I square RT. H equal to I square RT. I hope it is very clear. Is it clear? So this is about heating effect of electric current. So V equal to W by Q, Q by T is I, V equal W equal to VQ, P equal to W by T, VQ by T, P equal to VI equal to P into T, V equal to IR. So H equal to VI into T, H equal to IR into IT, H equal to I square RT. So this is about heating effect of electric current. Heating effect of electric current. Okay, so next one. Next. So electrical appliances already we discussed. Now we can see, so positive terminal has lead insulation, negative terminal has black insulation. So the potential of live wire is 220, the potential of neutral wire is 0, potential of earth wire is 0. Potential difference between live wire and neutral wire is 220 volts. Okay, so I hope it is very clear. That's enough for today class. So thank you so much for joining and attending. This is your Shiva sir from Student the Brand. If you like the explanation, if you like the content, if you like my channel, so do like, share and subscribe to Student the Brand. So thank you so much. See you in the next class.